Welcome to my project bazaar. Let us see the title of our project: Novel Design of Secure End-to-End Routing Protocol in Wireless Sensor Networks. Let us see the abstract of our project. In wireless sensor networks, the secure end-to-end data communication is needed to collect data from the source to destination. Collected data are transmitting in the path consisting of connected links. All existing end-to-end routing protocol proposing a solution in which each link uses a pairwise share key to protect data. In this project, we are proposing a novel design of secure end-to-end data communication. We adopt a newly published group key pre-distribution scheme in our design, such that there is a unique group key called a path key to protect the data transmission in the entire routing path. Especially, instead of using the multiple pairwise shared key to repeatedly performing a encryption and decryption over every link, our proposed scheme uses a unique end-to-end path key to protecting the data transmitting over the path. The proposed CAN authentication the sensor to is establishing the path to establishing the path key. The main advantage using this our protocol is to reducing the time needed to processing the data by intermediating the sensor. Moreover, our proposed authentication scheme has complexity where n is the number of sensors in the communication path, which is the different from the all existing authentication scheme, which are one-to-one authentication with complexity of enough to. The security of the protocol is computationally secure. Let us see the flow of our project. First is on a network model. The simulation work has been done within the network simulator NS2 version 2.34. The network formation is an accepts of creating nodes of network and transmitting the data. Networks of 25 nodes is created using the network simulator for a wireless sensor network. Then routing path discovery. The route request sent to all the intermediate nodes between the source and the destination. Route discovery for a shortest and freshest path. When the source node need to find the routing to the destination, it starts route discovery process based on the routing the location of the destination. Upon the receiving the route request, packet immediately nodes update their routing tables for resource route to the source. After reaching the destination, node sends route reply packets to the source node, transmitting the data from the source node to destination node through the energy efficiency intermediate nodes. If any path failures occurs, again start the route discovery. Encryption and the decryption is done by an RSA algorithm, detecting of misbehavior node using the security packet, then send the communication between the source to the destination. If the valid communication means sends the data transmission, otherwise it is an invalid node. The proposed system using the homomorphic encryption for encrypting the data packets and uses hash functions for verifying the length of the digital signature scheme for authentication. If the authentication is successful, then it sends the data packet through the reliable routing path. RSA providing the end-to-end confidentiality and hop authentication. Finally, we are calculating the performance evaluation. A different network parameter analyzing is being done for a proposed protocol. The parameters like a total energy consumption, throughput, packet delivery ratio, and delay are calculated here. Now let us see the output of our project. First, open the terminal window. Now type cd space e2 e routing. The e2 e routing folder containing our project coding files. Now I change the directory, then type ns space main.tcl. This coding is used to run our main.tcl file. The ns means network simulation. Now I entered. Here creating the node ID and the certificate ID using the RSA algorithm. The RSA private key 1024-bit long modules. For each and every node containing an individual node ID and the key values. The encryption is group key based done and the decryption key is separated individual keys. If the decryption key is matched means that is a invalid matched means that is a valid communication. The mismatched means that is an invalid key. So the invalid key nodes does not have any communication. This is an attacker's node. The encryption is done on source side and the decryption is done on destination side. First I open the out.nav file. This button is a rewind button, this is playback button, this is stop button, and this is a play forward button, and it is a force forward button. This is time simulation, and this one is a speed setup. Now I play the project. First one is an E to E, that is an end-to-end routing start. The magenta color circle indicates the end-to-end routing. Source node is created and the receiver node is created. Receiver node is nothing but it is on a destination node. Now 6th node sends all the neighbors nodes, sends a request message. The 5th node only now respond, so sends communication to the 5th node. The each and every node containing a node ID and then a key value. Now attacker is find 10th, 0, 24 and 20 and 15 node is an attacker node. So if any communication sends to tens means tens did not send other node communication. Routing is done here. The packet is dropped. 10th node want to send a communication to the 9th node, but 9th node did not receiving any communication because the decryption key not done here. So the source to destination communication is 6 sends communication to the 3, 3 sends communication to 22, 22 sends communication to 4, 4 sends communication to 17. The 24 is an attacker node, so the packet will drop. The destination reached the communication done and reached the communication and decryption is done here. Thank you for listening. Demo is completed.